and welcome to RC Plane Lab. I'm Ron.
I'm Tom.
Today we're talking about servos.
Servos.
Servos are exciting.
They are exciting. Well, they're really important.
They're very necessary.
They are necessary.
There's a lot.
They come in all sorts of different sizes
And shapes.
and colors
And outputs.
and inputs,
And power consumptions.
weight,
Heaviness.
sizes, colors,
Footprints.
footprints.
Bignesses.
Yeah, so there's a lot of servos out there.
What's a servo, Tom?
Well, a servo is the actuator that physically moves the control surface that you want moved via a linkage of some kind on your airplane. Basically, it takes the signal that your receiver is getting from your transmitter. The receiver sends that signal to the servo and electromechanically moves your surface.
Nice. Big word.
Yeah, I know. I was actually able to pronounce it, too, the first time.
You did a great job. We're all proud of you. So it takes the rotational force, the rotational movement, I guess, of a motor,
Right.
and creates a linear force,
Right.
Which is what you can use to move your control surfaces.
That's right. Yep, exactly. Well put, sir.
And that's about the only thing I'm going to have to add to this whole
That's
conversation.
not true. Hey, while we're talking about servos, why don't we talk about this week's tool of the week?
It's time for RC Plane Lab's Tool of the Week.
The servo tester.
Handy dandy little tool, perfect tool for setting up your servos without having to fire up your complete radio system.
Especially for how cheap they are.
Yeah, they're really not very expensive at all.
I bought a 3-pack on Amazon for under $15.
Yeah, and for the function that they perform, very handy tool to have multiples of.
Yeah,
actually.
what I like is when I'm setting up an airplane, I don't have to get out the receiver. You don't have to bind it to the transmitter.
Nope.
You don't have to go through all that work just to set up a servo. All you do, plug it into the servo tester, and not only can you center it to get true center for when you're setting them up,
Yep.
but you can also run it through its program to where it will sweep from full throw to full throw.
Yep.
Or you can use the knobs that are built onto it to set it to a specific point.
Yeah, for a manual control. Mm-hmm. Yeah, it's handy not only for finding the center of your servo, but you can also use it to diagnose problems with your servo, a noisy gear train, which we'll talk about here in a little bit. Maybe a dead servo could be diagnosed pretty easily with one of these things before you go installing it into an airplane and finding out the hard way, that you have a servo that doesn't work. So
Yep.
handy tool to have. I've got one. You've got, like you said, several.
4, I think now, but yeah. Oh, yeah. I mean, like I said, I keep them in my boxes.
Yeah.
It's good to go to the field with you in case you need one.
Yeah,
It's good to stay at home with your toolbox if you need to set stuff up.
Yeah, it's a good little
yeah.
troubleshooting device. So, yep, that's our tool of the week this week.
For a good reason.
Yeah, very good reason.
Everybody should have multiples.
Hey, while we're, I'm going to get on my soapbox here real quick. Since we're talking about servos and we just covered the servo tester, there is a right way and a wrong way to assemble your servo when you get it out of the new package or the box or whatever. And what I'm talking about is the brass or steel eyelets that go in the grommets. And like I said, there's a right way and there's a not right way to install those.
I'll be honest. I learned how to do it the right way from you, and it completely makes sense, and I never even thought about it beforehand. Most of mine were installed upside down, and that's bad. That's very bad.
Well,
that's not good at all.
It's not usually going to attribute to a catastrophic failure of some kind, but it's just bad practice. And you're not the intended use of the servo. You're not getting that full measure of what that servo can do unless these grommets and eyelets are installed correctly.
Correctly.
Yeah. And the instructions that come with your servo, if your servo comes with instructions, they usually tell you exactly how to install them. But I'm going to go ahead and tell you how to do it.
Who reads instructions, by the way?
Right, exactly. So listen, the brass or steel or aluminum eyelet that
Which normally it's brass.
normally brass. I've seen steel ones and aluminum ones. It has a flanged end, and then it has the other end obviously is not flanged. It's designed to be inserted into the rubber grommet that snaps into the ear or clamps onto the ear of your servo.
Which, by the way, the easiest way that I found to install those, because they're always a pain if you don't use a tool to install them, when you're actually putting the grommet through the rubber grommet thing. Did I make sense? When you're putting the
eyelet.
piece of eyelet, okay, yeah. So when you're putting the brass eyelet through the grommet, easiest thing that I found to do is I use one of my smaller Allen wrenches,
Oh yeah, that works too.
and then it slides in a lot easier.
Yep. I use my little number, I think it's like a number 0 or something like that, Phillips screwdriver out of my little jeweler's screwdriver case that everybody seems to have one of. And I slide them on there, stack them on there, flange side down.
I do too now.
And then you can use that to shove them in the grommet. And speaking of the flange goes down. The flange goes on the bottom of the servo. And the reason for that is you want the flange making contact with your servo rail or the wood surface that you're mounting the servo to, such that when you take the flanged screw that comes with your servos and you thread that down in on top, you're then creating a nice pocket that you cannot compress beyond a certain. Let me just say you can't overcompress it because you're cinching that screw down on the unflanged end of that eyelet, and you're creating that perfect pocket for that rubber grommet to do its job, which is to absorb vibration that can be harmful to electronics, like we covered in the prop balancing episode.
Yeah, and it's also good on like the drivetrain and stuff in the servos too, because if for some reason let's just say a tail wheel, let's say it's a servo for your rudder. If you land a little bit of an angle or something and your tail wheel hits the ground out of whack, that's a lot of strain that goes through to that servo.
Absolutely.
And that bushing, the rubber grommet, whatever you want to call it, is a nice little shock absorber for that to kind of take some of that strain off of the servo.
Absolutely. Yep. Where you don't have to rely on the gears to absorb that shock, where, if you've installed the eyelets correctly, you'll be protecting your gear train. And making your servo last longer.
And see, I always like to over tighten things anyway. So when I did that, before it was like, these need to be tight. You don't want them to move. Well, you actually do want them to move.
A little bit.
Not a lot. You're right. But you want to have a little bit of play in them so that they can do their job.
Exactly. Yep.
So yeah, even I learned something.
There you go. So I'll get off my soapbox. That's the correct way to install the eyelets in the grommets on your servos. Flange side down. Just remember that, and you'll never go wrong. So let's cover a few definitions, right? So we talked about servos. There are some terms that go along with servos that not everybody understands. So we'll start with the arm, a servo arm, right? It's not like an arm, with a bicep.
Look at
and
them
stuff,
muscles.
but the arm is what bolts or screws to the output shaft, which we'll cover in a second, that actually transmits that motion and converts it. It doesn't convert it, but it moves in a linear fashion, kind of a circular linear fashion.
Well, it moves in an arc.
In an arc, right. But this is the device that mounts to the output shaft that you connect your control linkage to. So that's called the servo arm. Usually when you buy a servo, it comes with an assortment of arms that are usually perfectly adequate for the intended use of that servo. Now, there are aftermarket companies that produce arms that are very high quality. Sometimes maybe you want a little more throw, so the arm is not long enough, which we'll talk about in maybe a servo setup episode or something like that down the road. But anyway, that's what an arm is. It's the little device, usually plastic, in most cases that come with your servo. It bolts to the output shaft. And that takes us to the output shaft. That's the shaft that's physically sticking out the top, or I guess there's some servos that have them out the top and bottom, which are kind of weird, but they're out there. You can find them on various places like Amazon. They're weird looking, but they're out there.
New ones, really.
Yeah.
I wonder what that's used for.
I would imagine if you needed something like a parallel.
Maybe like robotics or something.
Yeah.
Okay.
But you'll see something like that if you do some shopping for servos. But the output shaft is like we mentioned, it's the thing that the arm is bolted to, and it's the thing that
It's
sticks out
splined.
of the servo that's usually splined or
Yeah.
squared or something like that, that your servo arm kind of keys onto, and then you screw it down.
And then the output shaft connects to the gears that are inside of the servo.
Exactly.
And those are I guess you could say the cogs that are inside the servo. And they're usually metal or plastic.
They can be metal or plastic.
And they're what kind of connect the motor to that output shaft.
Exactly.
Because, believe it or not, there's a lot that goes on inside of a servo. It's
Yeah.
not just a simple motor that goes straight to an arm.
Right.
There's a lot of gear reductions and
Exactly.
a potentiometer and all that kind of stuff that's connected to it. So that's what the gears do, is it connects all that together. And you can strip your gears,
Absolutely.
which is a very bad thing on a servo.
Yeah, and we'll talk about a little bit about the advantages of different types of gear trains and things like that. So that's the definitions. There will be a few more definitions later, but those are specific to those particular applications. So basically, there's two types of servo with different kind of variations of each type. So there's analog servos and there's digital servos.
What's more common now, by the way?
Digital servos are really kind of becoming the norm, whereas analog, back in my day, there was no such thing as digital servos. And really, the only difference is an analog servo, it receives the command or the pulse from the receiver at a rate of, it's approximately 50 times a second. So basically that servo is able to understand and move, or I should say understand and interpret the signal from the receiver 50 times per second. So,
Which is 50 hertz.
okay. I'm not
Okay,
an electronics guy, but
Sure.
so if you want to think of it, so in a second, that servo can move 50 times. So if you think of time as being infinite, so in an infinite amount of time between 0 and 1 second, that servo could move 50 times. The rest of that infinite time, it's sitting still. I mean, we're talking minuscule amounts of time, but that servo is only going to receive and understand a command from the receiver 50 times per second.
But that doesn't mean it's sitting still. You said it's sitting still any other time. It'll still be moving and doing its job.
Right.
But it won't be interpreting the signal and trying to get it.
Right.
50 times it's written where it's supposed to go.
Exactly. If you want to understand it, so at millisecond, so from 0 to 1 second, we have, let's say, 50 milliseconds of time. At millisecond 29, the servo is trying to find position A, and it's going to continue to try to find that position A until it receives the next command at millisecond 30. So if you try to give it a command somewhere in that time frame, it's going to go to that last commanded one and then try to find your next one. Does that make sense?
Yes.
Without getting
You are correct in the basics, but the 50 milliseconds in a second is what threw me off. Because that's not.
Well, let's say from 0 to 50 milliseconds. At millisecond 29, the servo is moving to your last commanded position, and then
Let's just say 50th of a second, 2/50th. I'm sorry, that's how my mind thinks. So I get more confused when we try and scale things. So if we break it down, yes, 1/50th of a second, it's going to get a signal. 2/50ths of a second is going to get a signal.
Exactly.
And that does break down to actual milliseconds.
Right.
But we're not going to do that now. But just so you know,
Thanks.
there are 50 times a second is when it gets that signal and tries to update the actual output shaft's position.
Exactly.
All right, and then digital servos work a little bit differently.
Right.
So tell us how.
Well, they're just faster. So a digital servo has a microprocessor actually built into the servo to speed up that processing time. So instead of 50 times a second, it can actually receive, understand, and process a signal 300 times a second. So the digitals are more precise because they respond quicker to your control inputs. They're not trying to find the last known position before they move on to the next one. So they're more precise and they are capable of their holding power is stronger because they're receiving that command more often than an analog servo.
So the nice thing about digital servos is the fact that while they might not receive the signal faster from the receiver because the receiver can only give signals, depending on how quickly it gives. What it does is actually checks itself more often and tries to correct more often.
Yeah.
Does that make sense?
Yep.
Is that what you were trying to go for?
Yes, exactly.
So it won't have as much, I don't want to say dead time because there's really not dead time, but it won't have as much space in between movements, if you will. You know, going back into that whole microsecond and nanosecond and all that fun stuff. So,
and you can usually tell the difference between an analog and a digital while they're powered on by grabbing the control surface and trying to move it. Like an analog servo, it's much more grainy, I guess, in its response. It's going to emit kind of a, in protest, it's going to kind of emit a low, kind of a rumble, growling kind of sound. Whereas a digital, because of the higher frequency involved, when you grab that control surface and try to move it, it's going to be a higher pitch, almost like a whining.
And a lot of times you'll hear them do that just when they're sitting there.
When they're sitting, yeah.
Yeah, because it's just trying to go back and forth between where it needs to be and just constantly correct itself.
Exactly.
Yeah.
Yep.
Okay.
So usually digital servos, there I go, scratching myself. Digital servos will usually outperform an analog servo of the same size and type, just because of the
way they're made.
the way they're made and
The electronics inside?
Exactly, and the way they interpret the signal and process it and all that kind of stuff. So
Okay.
yeah, so digital servos are here to stay, and they're pretty much becoming the norm. But you can still get analog servos out there, and they're usually quite a bit cheaper.
Yeah.
So
And there's really nothing wrong with them.
no, not at all.
That with what we fly, what we do, analog signal or analog servos work just fine.
Sure. Yep. Another kind of a variant of digital servos that are fairly new, and when I say fairly new, I mean within the last 10 years or so, high voltage servos that are capable of processing or of operating at the higher voltages, say that like a 2-cell LiPo will provide. You can run those servos with that type of battery without a voltage regulator.
Yeah. So we will get into setting up servos and all that stuff in another episode, maybe even next week, depending on how things go.
Yep.
But definitely, like most most servos, if I get it right, are not happy with higher voltages and they will burn out.
Yeah.
So a normal analog signal, I did it again. Normal analog servo is only supposed to be ran off like your 6-volt battery. You're not supposed to go up to the 7.2 or 8.4s on them.
4.8 to 6 volts is where the
6 is the
designed
highest
to be ran. Yeah.
Right.
Because of the motor. It's just because of the motor that's in the servo.
Yeah, it's not made to take the higher voltage.
Exactly. So the higher voltage servos are out there. They're quite a bit more expensive, but like I said, they do allow you to operate with those LiPo batteries without any kind of a regulator or a regulating device designed to bring the voltage down in a more servo-friendly voltage range.
Well, and that's nice because that's one less thing to worry about in the setup of your airplane.
Oh, absolutely.
So if you don't have to worry about a voltage regulator or like the SmartFly EQ6 that has the voltage regulator built into it, or separate voltage regulators for each battery, it just makes it so much easier not to have to worry about that.
It does. Yep.
It doesn't mean it's bad to have them.
No,
but it's
not
just
at all.
one more failure point that I don't want to have to deal with if I can get away with
it's
it.
more wiring in the airplane, and a voltage regulator develops heat, because it's bleeding off some of that extra voltage, and it's got to put it somewhere. So there's usually a heat sink on the thing, and they can get hot. So I like the high voltage servos. I don't own very many of them because they are kind of expensive.
Yeah.
And most of my airplanes, let's be honest, analog servos are good enough.
Yeah, and when we're talking about running a battery like a 2-cell LiPo or something, we're not talking about a normal electric airplane that has a BEC.
Right.
So the BECs will actually take it down to the correct voltage to where you don't have to run high voltage servos.
Yep.
We're talking more about bigger airplane setups and things where you have a gas engine and you're still trying to run usually like 2 battery setups and that kind of stuff with bigger airplanes.
Yeah.
So.
Yep. Perfect. So another variant of digital servos are the programmable servos.
I have absolutely no experience with those.
I have a little.
Okay.
So without being too judgmental and saying you should do this or you should do that, I'll just say what a programmable servo does, and we'll leave it at that. I'll keep my opinions to myself. But High-Tech, they make programmable servos. There's probably other companies that you can program servos also. And it's basically just a digital servo with a internal processor that you can then program certain parameters of the servo. For example, on some of my High-Tech servos, I can plug in my servo tester, which is also a programmer from High-Tech, and I can actually program whether the servo travels in reverse. So I don't have to use a servo reversing on the transmitter. I can also program variable torque limits so that I don't over torque or overpower the electronics in the servo, like a voltage protection. I can program the deadband width. Like I can make it really, really no deadband, or I can add a little bit of deadband. I'm not sure why I would do that, but you can do that with a programmable servo. And
I think the wider the deadband is, the less whine you're going to have out of them.
Oh, well, there you go. That makes perfect sense.
Yeah.
So there are programmable servos out there. I own a few, and that's just another variant of a digital servo. Like I don't think there's any analog. I might be wrong, but I don't think there's any analog programmable servos out there. Usually, if somebody's looking,
because analog wouldn't have the chip in it. So you have to be digital in order to do that. But where I can see digital servos being nice is the fact that you can get away with, I don't want to call it a dumb setup, but once again, with a programmable servo, you get rid of extra parts.
Yes.
So you don't have to have a matchbox if you're running 2 servos on an aileron. We have a couple of those out here. You can just program that servo to do endpoint adjustments. That way you can get them to match the center. You can get those to match that way too. And it's just so much easier to set them up singly with a programmer than it is to run it on a board.
Right.
And like I said, it's just one less point of failure.
And if you're limited on the number of channels on your transmitter, you could set up 2 servos, program them individually, and run them off of one channel without having to do the programming on 2 separate channels.
Yeah, using a Y harness.
Exactly.
Yeah.
So that's another advantage of it. Like I said, I own some. It is actually not my preferred method to run multiple servos.
Really?
I actually prefer to do the programming in the transmitter if I have the channels available.
Oh, but see, that gets to be a little bit more difficult because that eats up a lot of channels.
It does, but if you have channels to spare, it actually, in my opinion, makes the setup easier because the feedback I get on my transmitter, I get it right on the screen and it's visible, and I can program it. And usually, you've got, at least on a lot of Spectrum transmitters, you have graphs and things like that. You can see most of your other brands are the same way, so you have that visible frame of reference when you're doing your programming. And when you're mixing channels together, you can make sure that they're exactly matching, and then you can go in there and fine tune one channel or the other without actually having to find the lead, unplug it, plug it into your programmer, power it up, and then it's a weird programming sequence, at least with my programmer, to actually program a servo.
Yeah, but I have to disagree with you on that one. I think for airplanes that are big enough to require like a matchbox or a programmable servo, I think it's so much easier to not have to worry about the setting in your radio than it would be to have the airplane set up correctly without using the radio.
Well, ideally, if you're ganging servos up on a control surface, let's say like on aileron, if you're using 2 servos to run one aileron,
right?
Ideally, mechanically speaking, the most ideal setup is to have it set up so you don't need to do any kind of programming or anything.
That's
not always possible.
That's hardly ever possible. I mean, because let's be honest, if you're trying to set up an airplane, you don't want those to fight each other at all. You want them to be perfectly in sync. Yeah. So getting a servo set up to where with the control surfaces, with the control horns, with all that stuff to be exact, that's difficult. Like I don't think I could do that.
So I'm going to counter that by saying not all servos travel linearly. Even servos of the same brand and the same type may not travel at the same rate over their entire range of travel. So you can set up expo and curves on your transmitter, and I don't know of any servo programmer that you can do that with individually on a servo.
Oh, I wouldn't set that up that way.
You would have to. Because eventually at some point through that arc of travel, those servos are not going to be perfectly in sync, especially if the servos are not, identical, and hardly any servo is identical to another.
No, but I think they're going to be a lot closer than trying to manually set it up. I mean, like, I think if you have it set up like with a smart board, like the SmartFly board,
Okay.
when you set those up, you set the center, you set the endpoints and all that kind of stuff, and you make sure that when you're running through that everything's right.
Right.
That's how I would set that up. And then for Expo, for all that stuff, I would use my transmitter.
Yeah, but between the two servos, you're not adjusting one or the other in that point. You're adjusting the channel, not
Yeah.
the two servos.
They run off the same
individually.
channel.
Yeah, but what I'm saying is through the arc of their movement, those servos are not going to be perfectly in sync. So you would have to then, on a separate channel, run a curve or something like that, such that if they get halfway through and they're off, you can adjust that with your transmitter with a curve. You can't do that with a programmer.
I did not have an issue with that on my Yak. I mean, that's all the experience I can say with that, but
I've never had that experience, so I'm just saying.
never had where they weren't linear, you mean?
Right. Yeah.
So are you just trying to argue?
Yes.
Oh, okay.
You like arguing.
I love arguing, actually. Yeah.
But,
But I think simpler is better than having the, like I said, on mine, I use the SmartFly switch or not the switch, the power, the power board kind of thing. And it just does a good job on its own because it has all the adjustments built into it.
Yeah. Yep, and that's a good way to set up a bigger airplane with lots of servos.
Yeah.
And the thing I like about the smart boards, we're getting off topic, but I like
That's
being
next
able,
week's episode.
I like being able to run up to 4 to 6 channels or 6 servos on one channel input, which is kind of cool.
Yeah, it's very handy.
So anyway, yeah, programmable servos. That's just a variation of digital servos.
So let's talk about some servo specifications.
Mm-hmm.
They are sorted by several different items. The torque it produces at a specific voltage is one way that we can classify them. The speed at which it goes from side to side, which to be a little bit more exact, I guess would be how fast it goes through a certain amount of degrees at a given
Time.
voltage and time.
Yeah. Voltage, yeah.
Which usually that's what, like 60-degree throws is what they kind of tell you for timing.
I think that's the standard advertising figure. Yeah.
And then they will classify them by physical dimensions, like sizing, and then by weight.
By weight, yeah. And the weight is important, even though it's usually last on the list. It's sometimes the most important, especially for small airplanes.
If you're building something small and weight is a factor,
Yeah.
then you want a lighter servo.
Yeah. So torque, this is a measurement of how strong the servo is relative to other servos. It's determined by multiplying the force acting on the servo arm by the distance from the center of the output shaft. I'm not going to get into the math of that, but basically when you're comparing one servo to another, a higher torque number means it's more powerful than a lower torque number.
Let me change that just a little bit.
Okay.
Instead of the amount of force acting on it, it's the amount of force that it can enact on something else.
Right. Exactly.
Okay.
Yep.
I'm with you now.
So one of the other specifications is, like you said, speed. Measure of how fast the servo is in general terms, usually within a 60-degree arc, and it's measured in seconds. So faster servos, if like a 3D airplane, you're hovering above the field, you want a pretty quick reaction because, a lot of stuff happens close to the ground when you're hovering. So
Very
faster
quickly.
servo, maybe as opposed to a high torque servo. And usually it's a trade-off, and they do it with gear ratios on the gear train, like we mentioned earlier. So a fast servo is going to have a different set of gears in it to provide speed at the sacrifice usually of torque and vice versa. So
I didn't
speed
know
and
that.
torque, there you go. The physical dimensions of the servo, there's so many different sizes of servos. They're tiny, tiny little. There's servos that are just basically PC boards with an electric motor and a worm gear. Tiny, tiny things all the way up to.
Those are those still considered servos? Or are those kind of more like a linear actuator?
Well, they're a servo actuator. They're still a servo actuator.
Okay, you're right.
But yeah, they do operate in a linear fashion. They don't have any arc to them or anything. But so really, really small, like not much bigger than a postage stamp, really.
You're right.
Almost as light. And then, we've got really huge, not so much anymore, but you could get servos that were like, the size of a fist. Well, you probably still can, but not so common for the RC airplane use.
Oh, you can get servos that are huge. I mean, if we're not talking RC airplane
Well, that's
stuff,
true.
I mean, servos get very big and pricey. But for RC airplanes, is there anything bigger like than the standard size?
There's still some out there, but thanks to technology and electronics and the improvement in electric motors and things like that over the last 20 years, we can get the power out of a standard size, which is a roughly 1.5 by 1.5 by 3/4 of an inch, roughly. Out of one of those servos that we could get out of a huge quarter scale servo, 20 years ago. So pretty much when
there were
there
quarter scale servos.
Yeah,
Okay.
there were servos designed for quarter scale, big airplanes. Big at that time was quarter scale.
Well, like what size were those? Do you remember?
I believe the standard air quotes was I think it was 2.5 by 2 by 1.25 inches. I think so. They were physically.
Oh my goodness!
They were physically big servos, capable of producing big power then. But like I said, now we can produce that power in a sub-micro servo.
That's what I was going to say. I was going to say sub-micro exactly, but you stole my thunder again.
I'm sorry. I do that a lot.
Kind of like you can get that same size out of a sub-micro servo.
There you go. Perfect. Torque, speed, dimensions, and then weight. The weight of the servo, obviously, how much it weighs. I mean,
which once again is important. If you're building a light airplane, you want to know how much weight you're adding to it when you actually put a servo in it.
But as far as specifications go, weight is probably the most simple to understand because it's just how heavy the thing is.
Yeah, like a 9-gram servo weighs 9 grams.
Weighs 9 grams.
Who'd have thought? I sure didn't think so.
So funny story.
Oh, go on, tell on me.
Ron thought that a 9-gram servo meant that it produced 9 grams of torque.
At a centimeter, which I did, and I was proven wrong. So I'll eat crow. Tom, you were right.
Well, to be fair, I didn't know. Remember?
No, but you guessed.
I did.
You guessed correctly.
I did. I guessed somewhat correctly. But at any rate, those
Actually,
are the 4.
I think you had it written down. Like when we were talking one time, you had 9 grams as the weight of it, and I was like, no, you're wrong. And I got all cocky and stuff, and then come to find out, I was incorrect.
At any rate, those are the 4 basic specifications that you'll see when you go shopping for servos. Another note about servos. A couple more notes, actually. The output shaft can be either bushing supported or it can be supported by ball bearings. The obvious, maybe not so obvious, but the advantage of a ball bearing supported crankshaft is longevity, number one, and the precision of the actuation. A bushing supported output shaft is going to wear a little bit quicker than one that's supported by a ball bearing, and it's probably not going to be as precise. You're probably going to have a little bit of slop in the output shaft,
because there's friction.
Yeah,
there's friction trying to stop it from going each way, so it's harder, more difficult, I should say, for it to get to where it needs to be.
Exactly. Which you can still buy both types of servos in both analog and digital. You can get bushing supported digital servos, surprisingly, which I didn't.
That is surprising.
I didn't know that, but I did my little search, and there were some out there. But anyway, that's when you see that. That's what they're talking about. How the output shaft is actually supported when it comes out of the case. It's either going to be supported by a ball bearing or a bushing or just the plastic of the case in some cases. And then metal gear and plastic gears. So metal gears offer advantages over plastic gears and vice versa. Each one has pros and cons. Plastic gears are going to be cheaper to manufacture. They're going to be cheaper to purchase. They're going to be simpler to manufacture, which contributes to the cost, I guess, the cheaper cost. They're going to be usually lighter. It's going to be a lighter servo than a similar servo equipped with metal gears. The advantage of metal gears, though, are durability.
Very much so.
For instance, while you mentioned earlier about landing and a tail wheel. So if you've got a rudder servo that's controlling your tail wheel, that tail wheel on landing and takeoff and taxiing is going to transmit some of that or all of that force back to the servo because the servo is connected directly to it via linkages that we talked about. So you don't want to transfer a lot of shock to the servo. So hopefully you've installed your grommets correctly and eyelets and all that. But in the case that that eyelet and that grommet setup doesn't absorb all the shock, if you have metal gears, it'll be more capable of standing up to the abuse of that rough handling that the tail wheel is going to provide than plastic gears will.
Yeah.
And plastic gears are easier to strip.
A lot easier to strip, and they just don't last nearly as long. I mean, like they wear out even much faster than metal gear does.
Yeah. So back in the day, I mean, metal gear servos have been available for a long time. Back in the day when we were still flying with 72 megahertz and 27 band and these other bands, the metal to metal contact of the metal gear servos could set up RF noise. Which was an issue that we had to be mindful of back in those days. But with the advent of digital spread spectrum and the 2.4 gigahertz protocols, it's not something we really worry too much about these days. So I like metal gear servos myself for most applications, but you certainly don't need them on a lot of applications. For instance, I can think, if you're operating like a bomb drop or something like that, plastic servos are probably going to be just fine because you're not using it continuously during the flight.
Throttle
servo,
something else where you don't have to have a lot of power.
Exactly. Don't have to have a lot of power. Probably don't need a lot of metal gears in there. Plastic gears usually probably going to suit you just fine for that.
Yeah, because there's not going to be a lot of pressure on it.
Exactly.
And your carburetor should open up and close very easily.
It should. Yeah. Hopefully it does. And if it doesn't, you probably need to take a look at the engine. But
yeah, a little gummed up.
Little. So now the fun part. Selecting the servos for your airplane.
Okay. I thought we were already at the fun part, but I'm glad that it's coming.
Well, it's all fun, right? We're talking about RC airplanes.
But what could be bad about it?
Right, exactly. So I'm just going to start by saying the selection of servos that are out there are overwhelming. I mean, it's so hard to pick. I mean, because there are so many options out there. And I just want to preface this by saying, yes, I can recommend a servo or Ron can recommend a servo, but keep in mind, we're not experts. We don't produce servos. We don't, we're not in the business of applying servos to specific, situations. I can only advise or recommend based on my own experience and likewise with Ron. So any recommendation we make, take that with a grain of salt. But I encourage you to do your own research. It's actually kind of fun. Just to see what's out there. And when you start doing the conversions, like for instance, when we're trying to convert torque from imperial to metric so we can compare servos and apples to apples, it's kind of fun. I like doing that sort of research. So just a word to the wise, we're not experts. So if I make a recommendation and you disagree with me, that's just fine. And you
normal.
Probably have a good reason. Yeah. So like I said, I'm not an expert and I don't think Ron would consider himself an expert either.
No.
At least not on servos. He is an expert on lots of other things, though.
I don't know what, but that's okay.
So, having said that, there are servos in about every conceivable size. So, I figured it would be easier to start sort of with the most common sizes. And I'll talk about what servos I would recommend for that kind of size application or airplane. It made sense to me to do it that way.
I think I know what you're trying to go for. We'll see how it goes.
Yeah, like a common size airplane, this is the type of servo I would use. That kind of made sense to me.
Well, a lot of them, like if we're talking ARFs or if we're talking even kits, they're made for a specific size servo.
Right.
Is that what you're talking about?
Yeah.
Like submicro and
there's sort of standard sizes. Yeah, exactly.
Okay.
Yeah.
So you're gonna pick your favorite type for each size servo. Is that what we're talking about?
Well, I'll pick my favorite servo for each standard size.
What did I say?
You said type.
Sorry. I guess I meant size.
Okay.
But anyway, cool. Let's move on then.
So I just want to say that in your airplane, your servos don't all have to match. Now, there's people are going to want to argue with me, and that's fine. Obviously, if you're using servos, excuse me, if you're ganging up servos on one control surface, or if you're going to do, like, for instance, one servo on each aileron, obviously you want those to match.
I agree.
But what I'm saying is your elevator servo doesn't have to match your throttle servo, or your air retract actuator servo doesn't have to match your rudder servo, right? So
Nothing says it has to.
exactly. So there are opportunities, I'll say opportunities, to save money in certain applications, because maybe you don't need a metal gear servo like we were talking about that's a little bit more expensive than a plastic gear for something like, an air retract actuator or a throttle or something like that. So you don't have to pick the high zoot, digital high torque servos.
What do you call it? High zoot?
High zoot, yeah.
I don't know what that
Maybe
is.
that's an old term. I don't know. Fancy. It's like another term for fancy.
Wow.
Look it up. It's out there.
Okay.
But
I'll look
anyway,
it up in my Funkin' Wagnalls.
In your what?
Our Funkin' Wagnalls. The old encyclopedias. You didn't have those growing up?
Funkin' Wagnalls?
Yeah. That was the name of the encyclopedia.
Oh, really? I
Yeah.
thought it was Encyclopedia Britannica.
That was after Funkin' Wagnall. Like
Oh,
Funkin'
really?
Wagnalls was we had when I grew up.
Wait a minute.
When-
you have a fact that predates a fact that I know?
Well, I guess.
That means
mean,
you're
like-
old.
No, it doesn't.
Yeah,
no,
you're
no,
old.
no, no. When I was growing up, because there was internet, I guess, when I was about freshman in high school.
Oh my God.
8th grade is when we got our first computer. Sorry. Freshman in high school is when I got internet and all that stuff on it. However, before that, growing up, going to school, if you had to do a project, we had, I don't remember if it was like 50 books or something like that, and they were the Funk and Wagnalls. And that, I guess, is who put it out or whatever. But it was the encyclopedia set.
It sounded like a dirty word you just said there.
It wasn't, I promise.
Okay,
And that was
if you say
what
so.
we had before we had Google.
Okay. Funk and Wagnalls.
So I'll look up your zoot suit thing, whatever
High
you
zoot.
said. High zoot.
Yes, high-zoot.
Okay.
Yeah, it's out there.
It's in the Funkin' Wagnalls.
Probably. So yeah, you don't have to use the same big expensive servo like on your throttle that you use on your elevator. Obviously, you want matched surfaces. You want those servos to match. Like, if you're two servos, one on each aileron.
Or
Obviously,
two on an aileron.
or two on,
or
an
two on a
aileron, or if you're
rudder.
ganging them together. Yeah,
If
exactly.
you're doing pull setup where you have two rudders or two servos for a rudder, you want both of those to match.
Right.
Correct. Okay.
So having said that, I'll start with the little flat foamies that are pretty popular. We all know what I'm talking about, the little foam board airplanes, Sandpiper, things like that. Servos in this range are usually labeled sub-micro because they're smaller than micro, which is
Which micro
sort of
sounds
a
pretty small to begin with.
yeah,
so
well,
if we're
these are
going sub-micro.
sub-micro. And then I think the one, I'm not even going to, I think they're called nano, the ones that are smaller than these.
Yeah.
But anyway, the sub-micro servo in this are in this sort of class. Ron and I use the popular 9-gram servo that we talked about. They get
The
them,
cheap blue ones,
yeah. Excuse me.
you can get them on Amazon.
Yeah, like a pack of what would you say? How many of them did we get for $1?
No,
earlier?
actually, I think it's like 20 of them for $10, maybe 10. I don't remember. No, 20 of them for 20 of them for like $10. No, I said that completely backwards. It's like 10 of them for $20.
There we
They end
go.
up being like $2 a piece. That
There
didn't
they
sound
are.
right when I said it. I couldn't figure out what I was doing wrong.
Math.
Wow, it's so hard sometimes.
So yeah, that's the little blue servos. Hobby King sells. I think they're probably all made by the same
Oh, I would
place, probably
think
just
so.
with different labels on them.
Yeah.
But yeah, they're called a 9-gram servo because they weigh 9 grams.
9 grams. Yeah.
They produce about 1.6 kilogram centimeters. I still don't know how to express that, but kilogram and centimeter is in there, which is roughly 22.2 ounce inches, roughly.
What do you mean you don't know? You don't know what it
is
means or you don't
is
know
it-
how?
No, I know what it means, but is it kilograms per centimeter? Is it kilogram centimeters? Is it centimeter kilograms? What is it?
It's how many kilograms it is at a centimeter.
Well, there you go.
Because it doesn't, I mean, it's not like linear.
So
So
from
it doesn't
this point
go
out,
up,
I'm
like-
just going to say kilograms and ounces. because that's how they're advertised.
Okay, so if you say kilograms, just know that he means at 1 centimeter from the center of the servo.
Thank you.
It'll lift whatever he says.
Right.
And if he is talking imperial ounces, it's 1 inch.
Exactly.
So it's actually quite a bit different of a measurement.
It is.
Because you're measuring an inch as opposed to a centimeter, and we all know that an inch is 2.54 centimeters.
Well, maybe not everybody knows that.
Well, we do now. I just said
Everybody does now. So the 9-gram servo produces about 1.6 kilograms of torque.
Which, by the way, is much more than 9 grams.
Which is quite a bit more than 9 grams.
9 grams is not much.
Yeah. So, which is, like I said, about 22 ounces of torque. They're really, really cheap. Like you said, you can get, 20 of them for like $1 or something like that.
20? Okay. It's $2 a piece is what they end up being.
But they generally range in cost from $3, and you can get some really, really, I'm going to say quality servos in this range that produce similar specs, probably a little bit more torque for about $30. That seems to be the going rate for servos in this range.
For a single servo, $30?
Yeah, they're out there.
It's expensive.
For a premium servo, I mean, they're out there. But
it's a lot more than $2.
Yeah, but there's guys out there that are, but there's guys and girls out there that are flying like indoor competitions and things like that, and they need a high precision, the center's perfect every time. So they're probably going to, probably okay with spending, that kind of coin on a precision,
For the common foamy, though, I would not do that.
Yeah.
For the common Dollar Tree foam board airplane or a small, cheap airplane, $2 servos are perfect.
Yeah. And well suited to the task. Really.
Right.
Like if you, and there's a caveat. So
always is.
They don't always, like these cheap servos, they don't always come to you alive. Like occasionally you may get a bad one, but at $2 and you factor that over the course of many purchases, a dead one here and there, it's probably tolerable for the low cost foamies that we put them in.
When I first bought those, I figured on half not working. They've gotten
I'm way
much
above that.
Better.
Yeah,
I mean, I
haven't gotten a bad one in a long time.
When I was ordering from Hobby King and it took a month or two to get here, if I needed 5 servos, I would buy 15 or 20 of them.
Right.
Figuring that some of them are going to be dead, but really lately, and I bought some of these cheap ones off of Amazon, they've been great. I have not had a dead one for quite a while, actually.
Yeah.
So I've been impressed.
Me too. Yeah, I've had similar experiences. So ultimately, what you choose is obviously up to you, and you have to weigh the cost of the servo against the how you feel about the airplane you're putting it in. If it's an airplane that's important to you, maybe you want to spend a little bit more. Myself, my next choice over the the cheaper ones that Ron's talking about, I like the Spectrum A330s. You can get those for around $10. They produce quite a bit more torque. I don't know what the number is. I didn't look it up. I should have. But for around $10 as a quality servo, and it centers really well. So on a balsa built 3D type airplane, I have a couple of those. I have those servos in that, and they perform really, really well. A little bit more than $2 a piece, about $8 more actually. But that's my choice for an airplane that I care about in the sub micro size range standard.
Yeah, so I would agree with that. For cheap, for lack of a better word, throwaway airplanes. I stick with as cheap as I can go. But those little chipmunks that we got that we still need to put together,
exactly.
I would not use what are they, SG90s, I think is what they're actually called.
Yep.
I would not use those in that.
Okay. Agreed.
Just my 2 cents.
Yeah, I agree 100%. So next up would be the next sort of standard that I kind of see would be like the larger scale type foamies, like maybe the big foam jets, or like maybe the big foam military, like warbirds, things like that, or balsa airplanes, kind of in the 15 to 25 size range. These servos in this range usually marketed as a micro. So not a sub-micro, but this is like our next step up. Generally speaking, they weigh in the servos in this range are going to weigh around 12 to 20 grams, kind of in that range, and produce about 35 ounces or 2.5 kilograms of torque. And again, the price range pretty wide. I mean, there's cheap ones on Amazon for about $5 and up, and you can spend up to probably $50. I would imagine there's $50 servos out there in this size range, or more, maybe even programmable ones are probably up there.
Probably so.
So my pick for this, so I'll go with 2 picks on an airplane that I care less about. Amazon has a cool 4-pack of these things for, gosh, I forget what they were, $21 or something like that for 4 of them.
Yeah.
And then, like I said, I really am a big fan of the Hi-Tech 225, which is, I think they call their Mighty Micro. Metal gears, it's programmable. I think it's programmable. But again, that precision centering, something I would put in like a nitro-powered 25 size airplane, which actually my Cloud Dancer 10 has those servos in it. So
Nice.
Yep. All right. So the next category, which really is kind of our last category because servos that are bigger than this next grouping really don't. I mean, I'm not going to say they don't exist, but they're not common. Like, so the next
They're not for us to worry about.
yeah. So the next standard would be like the standard size servo, which generally fits in a 1.5 by 1.5 by 3/4 inch socket or profile or whatever. That is the standard size servo. Many years ago, that was the size or standard by which all other servos were measured because it was the most common.
Still is, I would think.
But the power that we can get out of this size servo now has sort of rendered the really large physical servos kind of unnecessary. I mean, servos in this range are just as at home in a 40 size sport plane as they are in a huge 42% yak in your case.
So if we're talking about powerful servos, the ones that I have in the yak are the JR DS 8711s.
Yeah.
Is that DS? Yeah.
DS,
8711s.
so. Yep. Digital servo, DS.
Oh,
yes.
that makes sense.
Yep.
Guess never thought about
There
it.
you go.
8711s, which I don't know what that means other than stupid expensive, at $129 a piece.
Yeah.
And over 400 ounces of torque.
That's a lot.
That's a lot.
And in addition to that, very, very, very high precision, like perfect centering. I mean,
So hold on. How many ounces are in a pound?
12 ounces? Oh, 16 ounces.
16
in a pound.
ounces. So what's 400 divided by 16? Let's just say
gosh,
400. So that means, this is very rough math. This means at 1 inch, that servo could pick up like 25 pounds.
That's impressive.
That's very impressive.
At
Like
one,
I've never
at one
thought
inch,
about that before.
that's overkill, I would
400.
think. Almost.
And there's 2.
per
I have
aileron.
2 per aileron.
Yeah.
Wow.
Yeah. So with the advances in technology, I mean, that's a prime example of what this size servo can produce.
6 volt, by the way. That's
At
6 volt.
volts, right.
That's
Yeah,
300.
that's not even a high voltage servo.
No, it's not. It's 300 and some odd inches at 4.8 volts.
Yeah, which is still a ridiculous number. This servo is the standard size. They can produce for instance, a Futaba S3003 or like an S148 if you're old school like me.
3003s are my entry level ones.
Right.
Yeah.
Those produce about 48 ounces
So
of torque. So in comparison,
12.
yeah,
It would take 12 to put the
So,
same amount
yeah.
of output. Wow.
rough math, 1/10. Yeah, rough math.
Or 1/12 to,
Or 1/12.
to be exact.
But I like
Okay, that's
even
still rough.
numbers.
But yeah, okay.
But anyway, so yeah, there's a wide range of performance in this standard, and also a wide range of cost in this standard. So we don't need to buy the big quarter scale size servos anymore because the standard servo is capable of producing the torque that we need. It's kind of common to shop for servos in this category based on their performance. So obviously, most people, I would assume most people are not going to spend $130 on an 8711 standard size servo to put in a 40 size sport plane.
Probably not.
Most folks probably wouldn't.
I wouldn't.
Some servos I found on Amazon that are maybe not, over 400 ounces, but for 180 ounces of torque, you can get a 6-pack of these things. I think I found some for $26 for a 6-pack, which
That's
would be
a good deal.
Yeah, it's a very good deal. So something like that in a 40 size sport plane, that sounds a lot better than $130 each.
So what do you think of using something like that in just a regular 40 size? Like, would you have used anything like that on your Duelist?
If I didn't already have the servos that I had, I did have to buy, I think I bought one of the Hi-Tech 225s for my retract actuator, and I bought the plastic gear version of that, just want everybody to know. But if I didn't already have servos, I probably would have. Actually, I would have taken a chance on those Amazon or on those cheapo servos that I can find on Amazon because
Really?
Yeah, the performance specs, even if they only produced half of the voltage or of the torque that they advertise, that's still more than, the standard by which this size servo was measured, 48, 50 ounces of torque. This still beats that in a standard sport size airplane. I would have no problems with that.
That is not the answer I expected.
Yeah. I understand because the Duelist does mean a lot to me.
Yeah.
But
and took forever to build.
It did take a while to build.
And cost you a fortune.
It cost a little bit of money. But the servos that are coming from, let's just say it, they're coming from China. Most electronics are coming from China now. These servos are probably made, maybe not up to the same quality control standards as, a premium servo, but they're probably, very, very close. And servo failure is something, it's not common. Even with Chinese servos these days, the quality has become nearly as good, at least in the standard range, and maybe the smaller servo. Well, I mean, even you mentioned you haven't gotten a dead 9-gram servo in quite a while.
No, I've not.
So I would take a chance. I would, plug them in and operate them, make sure they're not dead, on arrival. But yeah, I would have taken a chance.
So let's be honest, like the JR8711, that's not a $130 servo. Like, the reason it's so expensive, I think, and I could be wrong, but companies that sell it, they advertise more. They have a much higher overhead than some of these ones that you get from China, from Amazon that are, $6, $7 a piece, that probably are not bad servos.
Right.
But the $130 servo also comes with, hey, if there's something wrong with this, send it to us, we'll fix it. If that happens on one of these other servos that you have that are cheaper, you're out. You just have to buy another one. Which still, by the way, if you think about it, you could buy like 40 of these smaller servos for the same price as one of the big ones. And I don't actually know of, like, I haven't done any testing. I'm sure somebody might have, but I've not seen anything that says a $130 servo is worth the extra cost over a $17 servo.
Yeah,
you know what I mean? Do you know what I'm trying to say? I
do, and I can attest. If you do a YouTube search of and any of the servos from Amazon, somebody, I guarantee you, has tested them on YouTube. And that
it's
might
still
be
hard to test longevity and all that kind of stuff. I think, but
I can almost guarantee you that. If there is negativity surrounding any of those servos, it should not be hard to find, is what I'm saying. Like if somebody,
so I see what you're saying. But
like if somebody has had a bad experience, either right away or long term, I'm sure it will be reflected in the reviews for sure. And
however, I get what you're saying. However, the JR8711 has been around for a decade.
Can you still get them?
Yeah.
Oh.
Yeah, I mean, you can still buy them. So that servo is the same servo that you can get a long time ago that you can still buy.
So is the Futaba S3003.
Right.
Also,
but I guess my point is, though, if some of these cheaper Chinese ones come in that don't have good reviews, if it's a bad batch or something, all they have to do, because these are names that we don't know, all they have to do is just rebrand it. Put a different sticker on it, and you think it's a different servo, whereas you have a big company standing behind some of these other ones.
Yeah.
Pros and cons. I know. I think I just talked myself into and out of different things by what I was saying. because it's really ridiculous, $130 for a servo.
Yeah.
However, yeah, you can get it fixed if you need to, as opposed to throwing it away.
Well, and you've had to do that.
I have.
Yeah. So,
But I'm still not ahead. By
well,
the way.
no, but
Like I said, I could have bought 40 of the other ones for
Right.
the same price.
but you also have that peace of mind. What's that worth?
I don't actually know. Like, I really don't know what that peace of mind gives me, because if it fails when I'm flying, no matter what I have in it, I'm kind of screwed.
That's true. That's true. So why not take a risk? Is the risk bigger? Is it more pronounced?
I don't know.
If you're
This goes back to the personal preference thing. You know, that's a decision you have to make for yourself.
exactly. Yeah. So in the standard range, a huge wide range of price and performance recommendations that it's hard to beat. $26 for 6 servos capable of producing at least 100 ounces of torque. That would be my choice for maybe an airplane like a Duelist. If it's something that I want a little bit more peace of mind or precision, servos in this category, I'm a big fan of Spectrum. Obviously, the A6020 is a good one. Savox, I think I'm pronouncing that correctly. I don't know.
Savox is what I thought it was.
Okay. They also make a nice one. I think it's a 253 MG. Both of those servos, the Spectrum and the Savox.
MG, I'm guessing, is Metal Gear.
Metal Gear, exactly.
There we go.
Both of those are available about $30 a piece, so quite a bit more than $26 for 6 of them.
Yeah.
But still, it's a quality servo that's going to be backed by a company that you can get service from if you need it. Hopefully you don't, but
Yeah.
so there you go. There's my choices in the standard size range. Obviously, if I need more torque, I shop around and find the one in this range that provides the torque I need. But rarely do I need a servo that produces 400 ounces of torque or more.
Well, you don't know that. I guess you do know that.
I'm
You're right.
pretty
No,
sure.
I don't honestly think I have anything that would need that anyway.
Yeah. So,
Like, I don't fly it
Yeah.
that where I would need that much torque.
Right. Exactly.
But it's cool to say you have it.
It is.
All right. So you think next time we can do servo setup?
Yeah. So I think we've
I don't want to go longer on this one because we are way long.
We've beat servos to death. So I think next episode, maybe even the very next episode, should be how to set up a servo
I think that's a good idea. So tune in next time to find out how to set up a servo.
or how we set up a servo.
Well, it's still how to do it.
It is.
Might not be the right way, but it's
our
a good way to do it.
And so far, it's served us well.
It's so far servoed us well.
Oh,
All right.
Very
Until
nice.
next time, I'm Ron.
I'm Tom.
Good night.
Good night.